Yes.
Okay. The first thing they're doing is they're giving you an equation here. Great. They want you to find v of 8. That means you're putting 8 into
into the t.
Into the t. So do you have that number?
I will right now. So it's just
I'm gonna get it as well, but you're just typing in 6,700 in your calculator.
right times 0.8 to 8 to the 8th power.
8th power.
I get 1124.07.
Yep. So 1124.07. Okay, this means after 8 years, that's where the 8 come from. The salvage value, I don't know what the drop downs are. Let me go back and grab them. Is v of $8. V of $8. It's a little awkward, but that's what it is.
Okay.
The derivative. So you have to be able to find the derivative of this thing, or use some online calculator to find it. The derivative.
Right. So you would do you just minus, so it'd be 6,700 times it'd be 8 times 0.8 to the 7th power, right?
No, this one is it's a number to a variable.
Oh.
And the derivative is number to the variable times natural log of the base. So this is your derivative down here. It's the original function times the natural log of the base. It's not a power, like you're used to x to the n.
Right.
This is n to the x, which is different. Sensing that's not clear.
So like the ln,
Yes.
What would that?
It's just a number. I mean, there's just natural log of 0.8. It gets a number. So the v prime of 8, you have to put 8 into this thing over here. 6,700. 0.8 to the power of 8 times the natural log of 0.8. It ends up giving you a negative number, which is correct.
Okay.
So you end up just
taking. You have
taking.
to find the natural log of 0.8, or do you just?
It's all of this. What B is looking for is all of this.
Okay. I'll just type
and
8 times ln. Okay, so negative 250.83.
Yep. So that's your answer to part B. This means that after 8 years, the salvage value is decreasing by v prime of $8 per year.
Okay.
Okay. Part C.
Negative. That makes sense.
Yeah.
That 250 each year.
Yes.
Okay.
Part C is not a calculus problem. It's asking when it's half of its original value. Its original value is 6,700. 6,700.
Divide that by 2. Well, divide all that by 2.
Well, we were trying to figure out when does this thing equal 3,350, which is what you just said. So you have to solve for t to do this. So you divide both sides by 6,700. Left side becomes 1/2. You have to undo the t with natural log. So natural log of 1/2 equals t natural log of 0.8. So t equals natural log 1/2 over natural log of 0.8. I'll be right back in 10 seconds.
Sure.
I am back. This is the number that they're looking for. Let's see.
Okay, I'm calculating it right now. 3.10.
Yeah, 3.11 years.
And then for the next question, we're gonna do question number 6.
Okay, moving towards it. Moving towards it. Okay. The demand for a new computer game can be modeled by P of X equals 52.5 minus 8 natural log of X, where P of X is the price consumers will pay in dollars and X is the number of games sold. Recall that total revenue is given by this thing. So that means you're going to multiply P of X by X. So that's what they want you to do in part A. They actually literally want you to take X, multiply it by 52.5 minus 8 natural log of X. You could actually, I think, put that in there and get credit. You could also distribute this, so it's 52.5x minus 8x natural log x.
Is that 8x or 8 times? 8x squared?
8 times x times
Okay,
natural
8.
log of x.
Okay. And that would be the answer?
Yes, for part A.
Part A. So I wouldn't have to calculate it, or
it wants it in terms of x. So it wants a function. It's expecting that.
And then for B, just find the derivative of that.
Yeah. Now that the derivative is power rule. So, and then product rule over here.
Okay. Could you explain?
Yeah. Let me. Okay. So the derivative of this first part is just 52.5.
Right.
For the second one, it's product rule. So this minus here. So it's you've got kind of two things here. So what's the derivative of 8x?
8.
Just 8. And then you keep the second one plus keep the first one times the derivative. What's the derivative of natural log of x?
Just natural log, correct?
It's 1 over x.
1 over x, okay.
Okay. And that all reduces. So this becomes 52.5 minus 8 natural log of x. And then these x's cancel out. And that negative, so minus 8. So this reduces to 44.5 minus 8 natural log of x. That's your revenue function. Okay. That's what goes there.
All right, and then C.
How many units will be sold if the price that consumers are willing to pay is 50? That's the demand. So C is the demand equation, which is this P of X. So it's going back to the original. So it's P of X equals 52.5 minus 8 natural log of X. And they're saying, well, what if price is 50? P of X. I'm sorry. No. I'm wrong here. P of X is 50. So 50 goes here
on the left side.
Yeah, and you're solving for
X.
Yeah, you're solving for X. Yeah.
Okay. So it'd be negative 2.5 equals 8 natural log of x. And then would you just
divide by negative 8, and then you undo ln with e. So you have
negative
2.5 over negative 8. The negatives cancel, and then you undo this with e. So e to the natural log of x equals x. That's how we get to this line. So it becomes e to the 2.5 over 8.
2.5 over 8 equals e. Oh, okay. So then the x just switches sides. Swaps over.
Yes.
Okay. Awesome. And then we're going to do 7.
Okay, let me get back to that. Okay, so I'm pasting that in. Okay, all right, so a lot of things going on here. They're giving you a revenue function, they're giving you a cost function, and they're telling you x, and dx dt means x prime equals 9. So normally we don't have to account for that, but we do in this problem. So they want the rate of change of total revenue. So total revenue is this first function over here. So they want r prime of x for this first one. So r prime of x is 4, but there's this, the fact that dx dt is here, that means that it's like the derivative of x is x prime, or dx dt, and you have to evaluate that. So it's 4 times 9, because that is x prime.
Okay, so it's that the little dash by the x, that's the prime. Or what is that? Is that a 1?
Yeah, it's x prime. I don't know. It's a tick.
Okay.
It's
Oh, okay, okay.
So dx dt takes longer to write than x prime.
Right.
But they're equivalent.
Okay. Yeah. 4 times 9. Okay. So that'd just be 36.
Yeah.
Okay.
So total cost is going to be that. And that one should have been done first, because that's more explicit. But your derivative of cost is 0.01 times 2x, but the derivative of x is x prime.
Okay.
So that's maybe a little bit confusing. Plus 0.2, the derivative of x is x prime. The
Okay.
derivative of 30 is 0.
Okay. So then you would just do
So you
0.2x or
start plugging in. So x is 20,
Oh,
x
okay.
prime is 9, plus x prime is 9, and you get a number out of all this. Which I'll probably have to grab a calculator for.
I got it. Plus 0.29. 5.4.
I get 5.4.
Yep.
Okay. Profit is revenue minus cost. Okay. So here's what you could do. You could set up R of X, you could subtract C of X, and then you could find the derivative and plug the numbers in, or you could realize that it's 36 minus 5.
Minus 5.4.
Yeah.
So 3.6.
Yes.
All right. And then we're going to do number 9, please.
Number 9. Oh my gosh, there's multiple parts here. Okay. It started when I see the scrolling, I'm like, oh wow, jeez.
Yeah, they really spared no expense on these questions.
Yeah, as a student, I mean, I think these are really hard. Like for me, I ignore all there's a lot of noise here.
Yeah,
And,
the worst part about my test is it's like it's on D2L, but it's not multiple choice. It's just a text box.
Mm-hmm.
So it's just, an absolute crapshoot sometimes.
Are you are you allowed to use like Desmos for this, or do you have to do this with
No, just a normal graphing calculator, and it's on Lockdown browser. So it's like the one where it's
Okay.
like tracks the eye movement and everything like that.
Okay. Yeah, this one is really long, but I mean it doesn't matter. I'm just trying to decide how best to show you. So
We
one
can
thing.
work on other questions if you want, and if we have time, we can come back to this because I'm not
I,
taking this test for a couple more days.
okay. I
I
would recommend that, but,
okay.
but I'll let you know if the next question is just more.
Okay, it's just question 10.
Okay. Okay, this is much more clear to explain.
Awesome.
I'm curious, are you doing any classes in person currently?
No, none at all.
No. Did any give you the option at some point to go in?
At some point, I mean, it was like up until probably a week before school started, I had 3 in person, and then they all switched, which is an absolute bummer.
Okay, so there's a couple of ways to do this. One way is to use the property of logarithms. So like the natural log of a over b becomes the natural log of a minus the natural log of b. Okay, that's one way to do this. Or you can just immediately apply the derivative rule to ln. Which do you think? Have you seen this other way, or have you?
Well, if I just did the derivative rule to ln, would it just be 7?
No, the derivative is if I give you natural log of something in here, let me call it
It'd be
x.
7x to the 6th.
The derivative is 1 over x times the derivative of x.
Okay.
So it's 1 over, so it becomes 1 over whatever's inside of here, which is that, times the derivative of what's inside of here, which is 7x to the 6th over 7.
Okay.
So a lot of good things happen here, but it just depends on what you prefer to look at.
Yeah, I would probably do the first one. It just seems a little bit more.
This natural log a minus natural log b.
Yeah.
Okay, well let's do it that way then.
Okay.
Let me repost the picture here, and I can always show you both. So what I just said is that this becomes the natural log of x to the 7th minus the natural log
Right.
of 7. This 7 comes out in front. Okay, so we're not doing any derivative yet. This is 7 natural log of x minus natural log of 7. Now, what's the derivative of this? Well, it's 7 times the derivative of natural log of x, which is 1 over x.
Right. And then the
So
other stays.
Well, this is a number. What's the derivative of a number?
0.
Yep. So this derivative is 7 over x, which the other one does reduce to. So let me show you that up here. This 7 cancels with this 7. You flip this fraction, so you get 7 over x to the 7th times x to the 6th. That cancels with that, so you end up getting.
Right. So you just get 7 over x, and then.
Which way is easier? I mean, I
I
think
would say that, yeah, the natural log.
This way looks better to me.
Mm-hmm. Okay. Question 14.
13, 14. Okay, so this is another rule. So this will be pretty straightforward to explain. It follows a recipe, and so what it is when you have y equals log base b to the x, the derivative is always itself times the natural log of b.
Okay.
So in this case, the derivative of this thing is log base 8 of x times the natural log of 8.
Log 8x times natural log. Okay. And you just do that on the calculator?
No, I mean, that's it.
Oh.
You're done.
Oh, really?
This is it. This is the answer. Sorry, I didn't make
Oh,
it
okay.
clear.
I just
That's
didn't know if you had to simplify it anymore. Or anything
you.
like
You
that.
cannot. I mean, the parentheses really go around that, and this is just off to the side.
Okay. All right. 15, please.
15. Okay, minimize q equals 2x squared plus 2y squared, where x plus y equals 4. The path here is you have to take this and substitute it back in, because we're comfortable dealing with things in terms of x. You're going to solve it for y here. So y equals 4 minus x. So this becomes 2x squared plus 2 times 4 minus x squared. So all I did was take that and put it in.
Right. And just throw it in there and then
Yeah,
just solve for that.
Well, you take a derivative. You're in derivative land,
okay.
so you take derivatives of everything. So this is 4x plus, this is power rule. So it's 2 times 2, 4. 4 minus x to the power of 1. The derivative of the inside function is minus 1, because the derivative of x is minus 1. You set this equal to 0. Okay. Hopefully you've seen that. Hopefully that's not too weird. You just,
Yeah, I think I've seen this before.
This is really so it's I mean, you could bring this negative over here. I should do that. So we'll call this minus 4. 4 minus x equals 0. 4x minus 16 plus x equals 0. So you end up getting 5x equals 16, and x equals 16 over 5. So you actually can tell when it's questions like that, because when the answer's like that, because it says use integer or fractions for any numbers in the expression. Let me, like right here, see where it says that? That's telling you like you're going to get one of those. So that's, I'm like, oh, okay, great. Y, as we just said, is 4 minus x, which is 4 minus 16 over 5. 4 is really 4 over 1. So that's 20 over 5 minus 16 over 5, which is 4 over 5. So that's x.
That's y.
And that's y.
Okay.
You'll get a slight variation on your numbers, but that is how you do that.
Yeah. Sweet. So that was 15. Okay, 16, please.
16. Okay, I'm gonna snip it into our workspace. All right, and employees' productivity and number of units produced. Okay, blah, blah, blah. All right, so this thing right here, it's a parabola. It's a parabola because it's a t squared. It opens down, so it looks something like that. And my guess is, without knowing it, that 40 is somewhere around there.
Okay.
So the maximum productivity is the vertex. So if you had a calculator, you could just find the vertex. Okay.
Right. You can just graph it and then.
You know calculus though. So the alternative here is you take the derivative, you find m prime of t, which is minus 6t plus 168, and you set that equal to 0. And then you solve for t. So t is going to equal 168 divided by 6. I don't know.
Negative 168, right?
Well, then it's divided by negative 6.
Correct.
So because it's got to be positive here.
Right.
Let's see if that works out nicely. It does. 28 years. So that's what they're looking for there. The maximum productivity is, well, that's this part right here is taking 28 and putting it back into m of t. So it's m of 28 is what they're asking you to find.
Okay.
So that's, again, it's got to be a calculator thing here. It's minus 328 squared plus 168 times 28 plus 190.
Okay, I'll do that right now. Uh, 2,542.
Sounds reasonable.
All right.
If you had just graphed it, your vertex would have been 28, comma 25, 42. No calculus needed in this.
Awesome. Okay, we're gonna do 17.
Okay. 17. All right, snipping it in. Determine the horizontal asymptote of the function. So in this case, there's if from your previous classes, there's really three cases here. It depends on the degree of the numerator and the denominator. They're both powers of 1. So your horizontal asymptote is y equals 12 over 20. It's the ratio of leading term coefficients.
Okay.
So it has 1. It ends up only having 1 horizontal asymptote. Type an equation, y equals, and then you need to reduce that 3/5.
3/5. Okay. Sweet. 18, please.
Okay. Snipping this in. All right, find the maximum profit and the number of units that must be produced and sold to yield the maximum profit. So profit in this case is R minus C. So we actually have to do R minus C this time. Last time we could get away with not doing it. So your profit of X is 5X minus parentheses 0.05 X squared plus 0.9X plus 2. You do want to distribute the negatives. So it's 5X minus 0.05 X squared minus 0.9X minus 2. This is a parabola again. So if you were to graph it, you would get something like that. And that's what they're looking for here. This is the X coordinate
They're
of
looking for the vertex.
and that's the Y coordinate of it. You can also use calculus. You can take a derivative and set it equal to 0. Both work. Both are totally fine. I'm going to take a derivative here. 5 minus 0.1x minus 0.9, and then you set this equal to 0. So you end up getting 4.1 minus 0.1x equals 0. So you end up getting x equals 4.1 divided by 0.1, which equals 41 units. And the profit comes from taking 41 and finding P of 41. So that comes from putting it back into probably that line right there. So P of 41 equals 5 times 41 minus 0.05 times 41 squared minus 0.9 times 41 minus 2. And I have no idea what that equals, but okay, go ahead.
When graphing, how do I, second calc, and then, or how do you find the vertex again?
Okay, so it's second calc max.
Max, got it.
Okay, and it's going to ask you, it's going to say left, and you need to
left
choose
bound and then right bound.
And then you guess at the same place, and it'll get right on it.
Okay, so yeah, X is 41, Y is 82.05.
Is it 85?
I got 82.05.
Okay. For the profit?
Yes.
Okay.
Okay.
It's reasonable. I don't know. I mean, it's,
yeah.
It's
try it again just to make sure. Yeah, 82.05. And then question 19.
19. All right, so quite a bit to do here, but this one's doable. I'm gonna do this a certain way where I snip in the equation, and then so there's a bunch of kind of lead up work to do to actually doing the things that it's asking for. Describe any relative extrema. So this is a parabola again. Would you agree with that? Because of the x squared.
Yeah.
It's positive, so it opens up. So it only has a min because it opens up. Is that reasonable? Like it doesn't have a max because it goes
I'm
up.
graphing it right now.
Okay. It gives you three options for actually. Let me pose those in here. The relative minimum. Yes, so it is, and you got to read these very carefully. It's B here. The relative minimum points are, and you're finding the vertex.
Okay. Second calc, minimum. I found. Yeah. Okay, so X is 1.5 and Y is 0.75.
Great. So the relative minimum points are 1.5, comma 0.75. That's what it's looking for there.
Right.
Now let's answer the next part, which is based on having the answer to this part. So I'm gonna snip it in here. It says identify where it's increasing or decreasing. So your parabola here, we know that this is 1.5 comma 0.75. It is decreasing in this side.
Right.
And it's increasing over here. So it's increasing and decreasing. So the answer is C.
C.
Okay, and now we got to fill these in. So it's increasing from 1.5 to infinity. It's the x coordinate.
Mm-hmm.
Nothing to do with y. And it's decreasing from minus infinity to 1.5. Again, it's the x coordinate. Now, perhaps the most useful thing that you've done for this question, which makes everything possible, is you graphed it, which is part D. It's just matching up your graph. They don't do a very good job of hiding the graphs, so yeah, it looks like that one's it.
Mm-hmm. Yeah. Was there a part C to that, or is that? Oh, okay. Never mind.
It is that those are the three parts.
Okay.
So I don't think this will change very much. I mean, I think it'll open up. I mean, you could get one that opens down. We've got time to go back and do, I guess, 9. Was it 9 or 7? What was it?
Could you look at 20 just really quick?
Oh, sure.
Awesome.
Sure. Oh, 16 pointer.
Ooh.
Is that really what it is?
It's just like the practice test doesn't. It's not for a grade, but unfortunately.
All right, pasting it in. It says find the absolute, maximum, and minimum values. On this interval. Okay. All right. So to do this, there's a lot that goes into this, but you first evaluate the function at the two endpoints.
Okay.
So if you could give me those values, that would be helpful. I'll check them
sure.
for you here, but we need those for sure.
So f of 2 is 32.
Okay.
-2 is 64.
Great. So now the next thing you have to do is you have to take a derivative. So the derivative of this function is 12x cubed minus 6x squared. That's power rule.
Mm-hmm.
You're going to set it equal to 0. You want to factor out as much as you can. You can actually factor out a 6x squared from both. You set this equal to 0. So that means 6x squared equals 0, comma 2x minus 1 equals 0. Here x is 0, here x is 1/2, and then you check if they're in the interval, meaning like from -2 to 2.
Mm-hmm.
And they both check out. So you take both of those are called critical points, and you come back here and you say, okay, well, what's f of 0 and what's f of 1/2? So f of 0 is 0, and now you got to put 1/2 back into your original function.
It's the original equation.
Yes.
So you get -0.0625.
Yes.
Or, a fraction.
Okay. So here, so I could ask a 2-year-old this question: which is the biggest number? And you're like, oh, it's 64. So that's your absolute max. Your absolute max is 64, and it's at x equals -2. Okay. What's the smallest number? Well, it's -1/16 at x equals 1/2. So by doing it this way, where you try the endpoints first, that's step 1, step 2, and then you take the derivative, find the critical points, and then do the same thing. You can get back to where you answer this question. Hopefully that was satisfactory.
Yeah.
All right, now can we go back to question 9?
Sure.
All right.
With what time we have left?
9's 20 points. That's interesting. Okay, I'm going to scroll down. I think it actually asks for a graph in the last part, is my guess. It does.
Okay.
That would be super good to have from the beginning. If from your pre-calculus, you're going to know that it has a vertical asymptote at x equals 0, because that's where the bottom is equal to 0. I know you can graph this, and then the horizontal asymptote is going to be at 5/1, because those are the coefficients, 5/1. So the graph here, let me snip that in. We're going to do that first, even though it's last there. It's going to tell us quite a bit about the rest of this. So we're looking for one with an if. They all have it at 0, but it looks like it's down to either B or C. Okay. Do you have your calculator handy to?
Yeah, I'll graph it right now. X. I think I did that one wrong. Okay, yeah. It's I got C. When I graphed it. I did 5x minus 2 over x.
Did you put the 5x minus 2 in parentheses?
I just did like the just the second fraction or whatever. But
okay. I am really bothered by that, so I'm going to graph it myself, because I'm like, no, it should be should be what I think it should be. But
Yeah, I got C again.
I of course make mistakes, and this is likely one of them. So yeah, it is C. So let me undo that. Whoa, I guess it's not that easy. Let me, there it is. All right. So this helps us with answering questions like, where is it increasing? Where is it decreasing? So see how it's going up and to the right?
Yeah.
It's increasing, and we're going to answer that question, but what we can almost do most of this without. It's increasing from minus infinity to 0. It's decreasing from 0. Oh, sorry. It is also increasing over here because it's going up and to the right.
Mm-hmm.
So it's also increasing from 0 to infinity. So I believe that's what it's asking for in, like, what we'll call part A-ish. So let me grab that, snip that in here. So it's increasing right here. So both of these intervals have to go in there. So it would be like minus infinity, comma 0, comma 0, comma infinity.
Okay, yeah.
Right. So determine the coordinates of relative extrema. So the problem with this one is that it doesn't have any. Like there's no places where it like reaches a min or a max, and we see that from the graph. Like
Right.
it just goes up. So the answer is actually there are no
relative.
Yeah. So if you get this question with just different numbers, it's going to be the same thing.
Mm-hmm.
The next part is determine the vertical asymptotes. We've actually already done that. So the
Right,
vertical asymptote
is 0, and
X
then
equals
the
0.
asymptote is y equals 5/1.
Yep, and the horizontal asymptote is the next question it asks. So actually, this is not as bad as it seems. It's just really long. So
Yeah.
you can it's y equals 5. The next question is slant asymptotes, which there are none, which I'll snip in. So there's no slant asymptotes. That would be if it went like sometimes you see these graphs that kind of go like this, but this one doesn't have any.
Just like sharp.
Mm-hmm. Yep. Let's see here. So then it's concave up, concave down. So this is such a terrible question because none of this happens. So they're asking you like all these things that don't ever happen. So concave up, the graph looks like this and like this. So this is where it's up because it holds water. This is where it's down because it does not hold water. So it's concave up. It's concave up on minus infinity to 0. That's
okay.
And down on 0 to infinity.
0 to infinity. All right.
And there are no inflection points. That's the next question. Actually, I'm gonna grab the next 3 because we can do them all at the same time here. Okay, determine the points of inflection. There are no inflection points, and that's because the asymptote, the X-intercepts are. Go back to the graph. Does it ever cross? Does it ever cross when you look at the graph? It does. It does.
Oh, it does. It does that.
Okay. So you set the numerator equal to 0. So you're going to set the 5x minus 2 equal to 0, and you solve for x. So you end up getting 2.5 or 5 halves, comma 0 for that. The y-intercept is when x is equal to 0. The problem is x cannot be 0 in this case. So there is no
y-intercept.
No y-intercept. And that actually completes the question there. About
Awesome.
15 parts.
All right. Well, thank you so much for this, Matthew.
Yeah, I'm going to send you the PDF of the notes and the video out here shortly. It doesn't take very long to process anymore. So if I can be of any more assistance, let me know. And if you ever need to book outside of what's available, just text me and I'll see if I can add it.
All right, sounds good. Thank you.
Okay, have a good night. Bye now.
You as well.